From the colossal blue whale ruling today's oceans to the towering Paraceratherium that once roamed ancient lands, Earth has hosted some truly magnificent giants. But have you ever wondered just how big a land animal could theoretically get before its own size became impossible to sustain? Welcome to Planetary Possibilities. My name is Rachel.
And my name is Arya. Our Earth, a marvelous orb floating in the vastness of space, teeming with life in a dazzling array of sizes and shapes, from the tiniest insects to the largest mammals. From the itsy-bitsy bumblebee bat, a whisker lighter than a dime, barely noticeable in the palm of your hand, to the mighty blue whale, longer than a Boeing 737, gliding gracefully through the ocean's depths.
It makes you wonder, what's the biggest a land mammal could get? Could we ever see something even larger than an elephant roaming the savannah?
Could we have a creature to rival the dinosaurs, those ancient giants that once ruled the Earth?
Well, sadly, physics plays a crucial role in determining the size of living beings.
Imagine a shrew the size of a car. It sounds fascinating, but its little legs would snap under the immense weight. Scaling up isn't as simple as it seems. The structure of bones and muscles must adapt to support the increased mass. Bones, muscles, even breathing, it all changes when you become enormous. The entire anatomy must evolve to handle the stress.
There's also the question of food. A giant creature would need an enormous amount of sustenance to survive. A giant needs a giant salad bowl, and Earth's resources are limited. The ecosystem can only support so much. So, while our imaginations might conjure up colossal creatures, reality sets some boundaries. The laws of nature and physics keep things in check. Still, it's a fun thought experiment. Imagining a world where giants and dwarfs coexist, each playing their unique role in the tapestry of life. Let's get serious about size for a moment. When we think about the natural world, size isn't just a matter of scale, it's a matter of survival and adaptation. Gravity, that invisible force, keeps our feet firmly planted on the ground. It's the same force that governs the movement of planets and the fall of an apple. But gravity also dictates how big things can get. It's a constant force that every living creature must contend with.
The larger an animal, the thicker its bones need to be to support its immense weight. This is why you see massive creatures like elephants with such sturdy, robust legs. Imagine an elephant trying to jump like a gazelle. It's a comical thought, but also a scientific impossibility. Disaster. Their bones would simply crumble under the stress. The physics just don't allow for it. Now, scale that up to, say, a mammal the size of a double-decker bus. You see the problem. The structural integrity required would be astronomical.
There's also the issue of heat. Large animals generate a lot of it, and managing that heat is crucial for their survival. Large animals generate a lot of it. Think of how much heat a single large mammal can produce just by existing. Think of a crowded room after a workout. The heat generated by all those bodies can be overwhelming. Now imagine that heat trapped inside a massive creature. Not pleasant. It's a constant battle to stay cool. So, while we dream of behemoths, nature imposes limits. These limits are essential for the balance of ecosystems. It's a delicate balance between ambition and practicality, wouldn't you say? Nature always finds a way to balance the scales.
Now let's talk about food, because even a gentle giant has to eat. Imagine a creature 10 times the size of an elephant. Its daily salad would be the size of a small house. Could our planet even sustain such an appetite? The answer, sadly, is likely no.
Land-based ecosystems, while diverse, just don't produce the sheer volume of vegetation needed to fuel a creature of that magnitude. Our oceans, however, are a different story. Whales, the largest animals on Earth, thrive on krill, tiny crustaceans found in abundance. This brings us to an important point. Environment plays a crucial role in determining size. Speaking of whales and elephants, these magnificent creatures offer valuable insights into the challenges and adaptations of being enormous. Their size alone is awe-inspiring, but it's their behaviors and interactions that truly captivate us. Both are remarkably intelligent social animals. They live in complex social structures, forming bonds that can last a lifetime. They've evolved complex ways to communicate, find food, and raise their young. Elephants use their trunks not just for feeding, but also for touching and signaling to each other.
Elephants, with their massive size, have a significant impact on their environment. They are known as ecosystem engineers. They fell trees, create clearings, and even dig water holes, shaping the landscape around them. This behavior supports other species by creating new habitats. Whales, on the other hand, undertake epic migrations, navigating vast distances to find food and breeding grounds. Their journeys are among the longest in the animal kingdom. Their sheer size is a testament to the bounty of the oceans. They play a crucial role in the marine ecosystem, helping to regulate the food chain. These gentle giants remind us that size isn't everything. Their intelligence and social behaviors are equally impressive. It's about adaptation, intelligence, and the delicate balance of life on Earth. By studying them, we learn more about the importance of conservation and the interconnectedness of all life forms.
So, while a land mammal the size of a skyscraper might be a stretch, imagine the traffic jams. It's fascinating to ponder the possibilities. Perhaps a creature with super efficient digestion, able to extract energy from even the toughest plant matter?
Or maybe one that can hibernate for years, conserving energy between meals. The truth is, Earth is full of surprises. Who knows what wonders evolution might still have in store? One thing's for sure, size isn't everything. Wink wink, LOL. If you enjoyed our video, don't forget to like and subscribe to our channel. Join us next week as we dive even deeper into the fascinating mysteries of planetary possibilities.